I've been having a lot of fun working on the gameBadge project lately. This Pico-based handheld is a neat little electronics project that you can make yourself without a lot of difficulty. Today, I'm going to take you through the software side of things. I'll show you how to install some games, and I'll talk a little bit about the emulator work that I've been doing as well. This is the third video in my gameBadge 2024 series. In the previous two videos, I walked you through the high-level architecture of the gameBadge and took you through the process of making one in a step-by-step tutorial. And if you've been following along so far, then you hopefully have a working gameBadge. Now early on, I said that this was going to be a three-part series. MGC 2024 is happening this weekend, and I really wanted to get a video out there on how to install games and emulators before the workshop takes place. And I also wanted to explain how to write your own gameBadge games. But because time's running out and I still have a ton of stuff to do for MGC, I'm going to have to cover the game development topic another time. So for this video, I'm going to show you how to load up some of the pre-compiled games and emulators, and I'm going to talk a little bit about some of the work I did in porting over some emulators for the gameBadge. The gameBadge uses a Raspberry Pi Pico with the RP2040 as its microcontroller, and this makes loading pre-compiled software very easy. This is because the Pico supports something called USB flash format, or UF2 for short. UF2 is an approach for flashing microcontrollers over USB. And believe it or not, it was created by none other than Microsoft. When you connect a microcontroller to your computer in UF2 mode, it'll appear as a USB mass storage device. And if you have a pre-compiled UF2 file, all you have to do is drag the file over to that drive. You really can't get much more simple than that. Ben and I both wrote gameBadge sample games for MGC last year, and you'll find both the source code and pre-compiled UF2 files in the GitHub repository under the code/sample games folder. There is, however, an extra step to take with gameBadge games that makes it a little bit more complicated than just dropping in a UF2 file. You see, the Pico has 2 megabytes of flash storage on board, and by default, all that space is dedicated for the program code. To make the gameBadge easier to develop games for, it was intended that you would allocate a portion of that 2 megabytes of flash as file storage for game assets. And both sample games make use of that approach. So first, you need to install a special UF2 file called flash_format.uf2. You'll find this file under the Utilities and Test Code folder in the GitHub repo. Download this file and then connect your gameBadge to your computer in UF2 mode by holding down the boot select button while turning it on. Your gameBadge will appear as a USB flash drive with the label RPI-RP2. Then, just drag the flash format UF2 file over to that drive. After a couple of seconds, the gameBadge will reboot and reconnect to your computer in UF2 mode. Next, you can copy the UF2 file from the game that you want to load. So to load my NES Tetris clone Badris, I'll just copy over the Badris UF2 file. And when the gameBadge reboots again, it'll now show up as a different USB drive with a volume label of EXT Flash. And if you look at the properties of this drive, you'll see that it has about 1 megabyte of storage. Next, you need to copy the game asset files over to that flash drive. For Badris, you'll just copy over the whole Badris folder. Then you can press the reset button on your gameBadge, and it will launch directly into the game when it starts up. Okay, so that's how you can load one of the pre-compiled games. And for this year's MGC, I thought about writing another gameBadge game from scratch. But the change in this year's design is the inclusion of a micro SD card slot. So to take advantage of that, I decided that instead of writing a new game, I would go ahead and port over some emulators. Now, the emulators come with a couple of caveats. First, they are nowhere near perfect. In most cases, I ported them as is from the MCUME project. The only changes I made to the code were the minimum needed to get it to run on the gameBadge hardware. So expect bugs, crashes, and other compatibility challenges with your ROM files. I'll continue to work on these and improve them over time, but for right now, they're pretty rough. The other caveat is that not all the emulators are 100% feature complete. For example, neither the Atari 2600 nor the Game Boy emulator have audio. I'll continue to work on these, and I would also invite others to jump in and help as well. All the emulators are in the code/emulators folder in the repo. In a similar manner to the games, you just need to connect the gameBadge in UF2 mode and drag the emulator's UF2 file over to the drive. To play your games, you'll need to copy the ROM files over to a FAT formatted micro SD card. Each emulator expects its games to be in a specific folder, and the game files must be in a supported format. In the emulators folder in the repo, I've included a README file, and this lists out both the folder and the ROM file format that each emulator expects. So if you have a game that doesn't work, that's the first thing to check. Also, some of the emulators require BIOS files, so you may need to acquire and copy those files onto the micro SD card as well. That information is also included in the README. At the time I'm recording this, there are 7 emulators available in the repository for you to try out. Now, I want to be clear. I did not write any of these emulators myself. I only modified the existing code to work on the gameBadge. Some of these modifications were very minor. For example, the Commodore 64 just required me to change a few variables and to recompile it. And some of them, like the Game Boy emulator, required a lot more work. Now, as I mentioned, I leveraged the MCUME project as the emulator source for quite a few of these. And those emulators were the easiest to port because MCUME already supports the ST7789 display as well as PWM audio. I did most of the work in Linux, and the reason is because the Pico's development toolchain just works better in Linux than it does in other operating systems. Now, even though I used Linux, for the development environment, I used Microsoft VS Code. Now, personally, I'm an avid VS Code user. I use it for pretty much everything. The extension library is vast and the Git integration is top-notch. For debugging, I used an extension called Cortex Debug, which is a debugger for ARM Cortex-based devices like the RP2040 that's used on the gameBadge. And for the debugging hardware, I used a Pico probe. Now that's a cool project. It allows you to use a secondary Pico to debug another Pico. So I Frankensteined one of my gameBadge devices to wire it up to the Pico probe. And to make that work, you have to connect the Pico probe to the serial wire debug pins on the gameBadge's Pico, as well as the UART pins. Then the Pico probe connects directly to the computer through USB. And by doing this, I'm able to use the Cortex Debug extension to set breakpoints, step through the code line by line, and examine what's in memory on the gameBadge. This type of debugging setup isn't required, but it does make life so much easier. And the other thing that was really useful in this emulator work, and really just in general when working with other people's code, was GitHub Copilot. This thing is magical. You can highlight a snippet of code and ask Copilot to explain what it's doing. And it does an unbelievable job. It makes working with someone else's code a million times easier. Now I'm going to keep working on these emulators for the foreseeable future. I have a list of about a half dozen other emulators that I want to port over, but at the same time, we're planning for next year's version of the gameBadge. And it's looking like we're going to move towards a different type of display. So in addition to cleaning up the emulator code and getting more features working, I'm also going to be modularizing some of it so we can drop in a driver for a new screen and have the existing emulators continue working. Alright, well that's it for this video. If you're going to be at MGC 2024 this weekend and you see me there, please come up and say hi. I would love to meet you. And if you're in the workshop, then I'm looking forward to spending a few hours together and helping you get your very own gameBadge up and running. Alright, I'll see you in the next video. But until then, go make something cool.